Now we were doing reactions of carboxylic acid. Can you remember this list?
Yeah, lithium tetrahydroaluminate. Yeah.
These are the important reactions of carboxylic acid with lithium aluminum hydride. Lithium aluminum hydride is a famous reducing agent. As an acid, the reactions like with the bases to produce salt. Number 3, phosphorus 5 chloride, phosphorus pentachloride reaction, and reaction with alcohols. In my record, we had started this last time.
Let me just check because we were at this reaction of carboxylic acids. Yeah, that's the last heading that we gave.
I think we started this list in my record.
No.
Lithium aluminum hydride, LiAlH4, is a powerful reducing agent. Look at this reaction. If you take propanoic acid and you put it to LiAlH4, remember LiAlH4 is a very strong reducing agent. It will convert a carboxylic acid into first into aldehyde, and later it can also convert it into the primary alcohol like propane 1-ol. You have to see the record that is this heading there in the record. In my record, we started this. In my record, we were last time doing hydrolysis. This was our last thing we did. Hydrolysis, nitriles on hydrolysis generate carboxylic acid. So you can double check if you have a record. Yes, Shay, do you have a record? LiAlH4 is a strong reducing agent. Li is a strong reducing agent. So can you please check what was last heading you have in your record? Yes, Shay, can you hear me?
Yeah, our last heading was reaction of carboxylic acid. That's it.
Okay, so let's put our first title here, number 1. Double check the heading. The heading is reactions of carboxylic acid. The reactions of carboxylic acid, there are 4 reactions of carboxylic acid. Reaction with LiAlH4, and as an acid, the reaction of carboxylic acid as typical acid. Phosphorus 5 chloride reaction with PCl3 and PCl5. Reaction with alcohols. I'm starting with lithium aluminum hydride reaction. LiLH4 is a powerful reducing agent, And let us make the word equation here. Let us make the word equation, that is carboxylic acid. If you provide a reducing agent, it will turn into an alcohol as a primary version. So this is my starting concept for today. This is the first reaction. Our chapter is carboxylic acid. We are doing carboxylic acid, and in this chapter, we are discussing the reactions of carboxylic acid. Remember, this symbol H is used for a reducing agent. Now you have to copy this as the starting work for today. Let me know once you have copied it. We need this reference, what we are doing. LiLH4 is a strong reducing agent. Acha, we are discussing the important reactions. These are my list of
This
reactions.
in this, an aldehyde doesn't form because as soon as
So,
an aldehyde forms, it instantly becomes an alcohol, right?
this is a good question. Normally, Edexcel is not interested in aldehyde in the reverse route. Acha,
Okay.
when you are oxidizing primary alcohol to carboxylic acid, then it forms aldehyde. Even they discuss the distillation method. They want students to remember that in the forward route, in oxidation route, aldehyde can be separated. This is possible. Now you have to understand a concept here, that separation of aldehyde is also an important skill. Acha, in the reverse route, when you reduce carboxylic acid, it will eventually go to primary alcohol. But in the way it should stop on aldehyde also. Now look at this. We can use LiAlH4. The syllabus says some books refer NaBH4 also, but our syllabus says that you should not use NaBH4. Even older marking scheme allow that. Our new after 2019, they emphasize that you should use LiAlH4. Now make a library. Make a library of some important make a library of some important oxidizing and reducing agents like you can say like K2Cr2O7 is a good oxidizing agent, like like KMNO4, like KMNO4 is a good oxidizing agent. Similarly, LiAlH4 is a strong reducing agent. NaBH4, NaBH4 is also a good reducing agent, but a weaker one. Look at the example. CH3, CH2, COOH plus 4H. It means we are reducing it. Now, on the right-hand side, we are getting propane 1-ol and we are getting water also. This is reduction of carboxylic acid. You have to look at it orally, but you have to absorb the equation 4H. 4H means it's a game of reduction.
That's the reducing agent in the bracket.
It's a LiLH4 is a reducing agent. Now look at these reactions orally.
So in this case, the aldehyde just it doesn't form because it's normally distillated, right? So like it can't form when it's
You're right.
getting
That
produced.
LiLH4 is such a powerful reducing agent that it doesn't stop over, it does not stop over aldehyde.
Yeah, and we also had another question. We don't use KMNO4 because it's a very strong oxidizing agent, right? And
KMNO4, normally our syllabus refer K2Cr2O7 when you are willing to convert alcohol into carboxylic acid. So when you
but
want to convert,
let's say we have a ketone, and then if it's like apparently if it's KMNO4, a ketone would get oxidized or something. It's very strong, right?
there is an exception. Normally ketones do not oxidize, but there is an exceptional case where ketone can also be oxidized under drastic conditions. But normally, as a thumb rule, ketones do not oxidize
Yeah.
in normal conditions. Secondary alcohols oxidize to become ketone, and normally ketones resist. Normally, ketones resist to regular oxidizing agent, but under drastic conditions, we can do that.
Okay.
Now, let's move to our next concept. This is number 2. Achha, there is a list of reactions of carboxylic acid. Now we talk about as an acid. What are the acid reactions? Acid plus alkali gives you salt plus water. For example, methanoic acid plus potassium hydroxide, and we get this. Look at this reaction. HCOOH plus KOH. It is KHCOO. This is a writing style. K can be written in front of it. Now look at the second reaction. Acid plus metal. I hope you remember these word equations. When you write acid plus metal, you get salt plus hydrogen. Lithium propanoate. Look at this. When you make a reaction, Li is plus and carbonate COO is minus. It's a salt. Acid plus carbonate gives you salt plus carbon dioxide plus water. Look at this. I'm again using ethanoic acid plus carbonate gives you sodium acetate plus carbon dioxide plus water. These are the reactions of carboxylic acid as an acid. All acids do these reactions. Equations are important to understand because they are different from regular reactions. In case of organic, remember that a carboxylic acid, whenever it is entering into a reaction, a carboxylic acid has an OH group. Look, when you say CH3, CO, here another O and H. When you put carboxylic acid as an acid, it will actually have this bond, which is polar, and this bond breaks and hydrogen ions are released. This is the acid behavior. This is the acid behavior, which is the reason how an acid of carboxylic version generates water and salt. So I first reinforce my concept over the carboxylate ion. Acha, as an acid means what? That these are the typical acid reactions. These are the typical acid reactions. So look at this. Now, please give the heading as an acid. Carboxylic acids are weak organic acids. I have made it like this. Please give the heading as an acid and copy this information with me. This is the template that how carboxylic acid will enter into the reaction. Now, this bond, OH bond, this one is polar. This bond is polar. And remember this concept that carboxylic.
This forms hydrogen bonding in water, right?
This is not hydrogen bond. Actually, this is OH bond.
No, no, but
Carboxylic.
this would form hydrogen bonding in water with the water
Right,
molecules.
Perfect. This is the terminal which forms hydrogen bond also. Carboxylic acids are weak organic acids. So you have to now copy this screen.
Do I copy this?
Yes, have you copied it?
No, no, writing.
Okay, let me know once you have copied it. Okay, have you copied it?
Yeah, copy.
Acha, this is the source of the discussion that how carboxylic acid will behave as an acid. Carboxylic acids are weak organic acid, but by definition, what are acids? According to Bronsted-Lowry theory, by Bronsted-Lowry theory, acids are proton means H plus, acids are proton donor. Now look at this, how carboxylic acid will work here. Look at this reaction. Remember that carboxylic acid contains a hydrogen. Carboxylic acid contains this red hydrogen. Acha, when you put it in water, let me put aqueous here. When you put it in water, it releases H plus ions. Look at this. And this is the reason that it is an acid. It's a proton donor. This is how a carboxylic acid behaves. So all acids should be capable, all acids should be capable of releasing H plus ions. All acids should be capable of releasing H plus ions. So R, C, O, and O, and then there is a hydrogen. Remember that this bond is polar and this bond has to break. This bond is polar and this bond has to break. This bond has to break during the reaction. This reaction is called ionization reaction. Achha, do you remember why some acids are strong and why some are weak? Remember the theory? Why it is a weak acid? An acid is weak when it is so. How we identify? What's the definition of this weak or strong acid? Look at this. And hydrogen ion goes into the solution. Look at this. This is ionization or dissociation. So this is ionization or dissociation. So now you have to observe this. See how this reaction is occurring. Now, so we make this concept that this is how an acid works. This is called dissociation or ionization. So carboxylic acid, like all other acid, now this is very important. If you remember this theme, that carboxylate ion is basically the product. Hydrogen ion is the product. Hydrogen ion is called proton. So have you identified it? Can you absorb it now? Can you understand this?
Do I copy this and write it, right?
No need to copy this, but you have to
Okay.
memorize this important concept, Shahi, that when you when you put a carboxylic acid, you make this ion RCOO minus. This RCOO minus. This is called carboxylate ion. Look at this. This is carboxylate ion. Now you have to copy this. This is to memorize.
Carboxylic ion. Okay. I copy this down, right?
Just copy this only.
All right. Yeah.
Okay. This is called carboxylate ion. Now, remember that whenever you put any carboxylic acid in water, it will react in this pattern. So different reactions forms are there. So it will always form a carboxylate ion. Look at the example, the first one. The first one here, HCOOH and KOH. KOH is an alkali. This is a typical acid-base reaction. This is a typical acid-base reaction. Second reaction, look, this is the second reaction, CH3, CH2, COOH plus lithium. Whenever acid reacts with metal, they form salt and hydrogen. This is the reaction. Third, acid plus carbonate gives you salt plus carbon dioxide plus water. Look at all these reactions. No need to copy them, but look up all these reactions carefully.
Yep.
You have to understand that how carboxylate ion is being formed. Okay, have you observed that?
Yep.
Now, these are the important reactions. Now look at number two. Number three, phosphorus 5-chloride or phosphorus pentachloride. Now we are discussing carboxylic acid with phosphorus pentachloride. this, this is the reaction. And we get POCl3 and HCl. They are typical fumes. And remember PCl5. PCl5 is an important reagent. Acha, first we should go for the, as usual, we should first go for the word equation. Acha, give the heading. Here, give the heading. Give this heading.
Isn't it PCl5?
PCl, oh, sorry. PCl5 on the left side. Right. PCl5 is on the left-hand side. This is phosphorus pentachloride. This one. Now you have to memorize this thing. You have to memorize the word equation. Copy the word equation, please. Okay, have you copied it?
Yeah, copy.
Good. Carboxylic acid plus PCl5 phosphorus pentachloride. Now, who is this acyl chloride? We have to introduce this in our library also. This is another very important reagent. Let us introduce it here. RCO, and here it is. Here it is, Cl. This is called acyl chloride. This compound or this family is called acyl chloride. Acyl chloride is a very important organic reagent. What's the meaning of organic reagent? It is used in making other organic compounds. So this structure RCOCl, this is called acyl chloride. This is a very important family of organic compound. It's an important reagent. Now look at this. For example, CH3 for example, it is CH3, CO, and Cl. We can also write it CH3, COCl. This is, and its name is ethanoyl chloride.
Do I copy is done?
You have to copy this also because structures should be copied always because they are very helpful. Acyl chlorides. What are their importance? Acyl chlorides are important organic reagents. What do you mean by the word organic reagent? It means that they are used in making other organic compounds. Let me know once you have copied it.
Yeah, just 2 minutes nearly done.
Have you copied it? Yes, sorry. What's the
No,
question?
just a bit more.
Okay, you have copied it, right?
Yep, done.
Okay. Now look at this conversion occurs with phosphorus pentachloride and it is the preferred method. CH3CO2H plus PCl5 gives you CH3COL plus POCl3 plus HCl. So famous steamy white fumes come out. Phosphorus trichloride will give you also acyl chloride, but with H3PO3. So there are two reactions in this list, but you have to memorize them. You have to memorize these reactions. One, which is prominent reaction, and it releases the steamy white fume, HCl. This is a test for carboxylic acid also. This first reaction is can be used as a test for carboxylic acid also. So now you have to copy these two equations. Copy them. I'm just coming in a minute. Copy these two equations.
Okay.
Now, can you see these reactions that the steamy white fumes, they can be used as a test for carboxylic acid. In the second reaction, the fumes are not coming up, but in the first reaction, you will see the fumes, and these fumes can be used as a test. Now, number 4. This is the fourth category of reactions. There are 4 reactions in our list. The reaction of carboxylic acid with an alcohol using an acid catalyst to form an ester. You have to now copy this.
You can do the reaction as well.
You're talking about this one.
Okay, that's fine. You go back.
Have you copied it?
Yeah, yeah.
Okay. Now give the fourth heading. Okay. Let me know once you have copied it.
Yeah, copied.
First of all, can you recall what are esters? Let us recall from our IGCSE this family of compounds. Achha, organic chemistry works on this pattern. You have to memorize all these intro lines that what are esters. Look, R, C, O, another O, and then the second alkyl radical, which is another R. You can say it's R prime. This is called an ester. We can also write it as R C O O R prime. These are called esters, and their IUPAC name is alkyl Their IUPAC name is alkyl alkanoates. Look at this. These are called esters. Esters contain carboxylic link, but it has double alkyl radical. Both sides are both sides are alkyl radicals. So now you have to copy the intro.
The naming is the R on the right first and then this, right?
There are two R's now. One is the first alkyl radical in esters. There are two R groups. On both sides, there are alkyl groups. So you can start with alkyl group. Even if you remember in ketone, I'm sorry,
The
in
alkyl
ketone,
group is the red R.
alkyl group is that CH3,
No, no,
C2H5.
in the diagram is the red R, right?
Right. But there are two
Okay.
alkyl groups.
Okay.
Okay. Have you copied it?
Yeah, copied.
So these are called alkyl alkanoates. These are IUPAC name, alkyl alkalo like methyl methanoate, ethyl ethanoate. This is called these are called alkyl alkanoate. These are esters. Now look up the word equation. Word equation is always important. Alcohol plus carboxylic acid, a reversible reaction, ester plus water. Esters are very important. If I can recall you our IGCSE concept, esters are sweet smelling compounds. They got the fame because of their smell, and they have a lot of applications in these type of things, like in food grade flavoring, in artificial smells. So they have a lot of application there. Secondly, in our IGCSE, ester had another application, that it is used in making polyesters. What are polyesters? Polyesters are artificial fiber which we use for our artificial fiber is used as a good alternate for cotton. So now you have to copy this word equation. That next Thursday, Shahid, is this you're saying that is 7th November?
Yeah, 7th, I remember.
Okay. And they are giving 11 to 14.
Yeah, 11 to 14 most likely,
But
unless
you
they
can
say
confirm.
15.
But once you confirm, you can post it on the chat. So we have a memory and we can put some questions practice there.
Okay.
But normally your school used to send you PDF of the syllabus outline and these type of things.
Okay, say that again.
Your school used to send you PDF, the print PDF form of just like what topics are coming.
No, not like that, no.
Oh. Okay. Have you copied it, the word equation?
Yeah, copied.
Okay, now look at this point that I am improving this sheet. I'm putting more knowledge in it. I want to highlight now that why we are using concentrated H2SO4. Now, this is a very important concept. Everyone knows that H2SO4 is a powerful acid, a strong acid. But this concept is not here. Concentrated H2SO4 is sitting on the arrows. It means it is a catalyst. When something is sitting on the arrow, it means it is not a pure reactant, it's a catalyst. Concentrated H2SO4 is used here as a dehydrating agent. This means it is going to absorb water on the right hand side. If you do not remove the water, the problem is that ester also have a strong tendency to react with water. So reaction will reverse and our product will be wasted. So our H2SO4 is an acid catalyst as mentioned here. It is an acid catalyst. It is also used here as a dehydrating agent. So you have to share this info there on the same sheet.
Again, can you say that again?
You have to copy this also on the same sheet.
Okay.
So have you copied it, updated
Yeah,
it?
copied. Yep.
So this chapter is nearly finished and we have to just finish it and start the next also. And you will have to confirm that how much syllabus is coming. And obviously the method is simple. You have to revise the notes and you have to do past paper questions on that. Everything is obviously the past paper work. So we are stopping here and we will inshallah continue in our next class. Allah
Okay,
Hafiz.
Hafiz.